Hey everyone! In today's video, we'll be talking about fin optimization in OpenRocket. You will learn how to create a really nice set of fins and also have fun doing that. Stick around to the end to see our tips and tricks that we have learned over the past few years. In today's video, we will be covering the 3 fin sets in OpenRocket. These are trapezoidal, elliptical, and freeform. You can see here that we have a diagram of a fin. This diagram shows you the terminology of each angle and also length. First up, we have root chord. This is what touches the side of the rocket. Next, we've got sweep angle. This is the angle that the air hits the fin at. Next, we've got the tip chord. And after that, we finally have span, which in OpenRocket is called height. Here I have a rocket with no fins. This rocket will be our example for the entire video. As this rocket has no fins, it will be very unsafe and you will not be allowed to launch it at all. As you can see, the center of pressure is a lot more forward than the center of gravity. This causes the rocket to go into negative stability. Therefore, we are going to need some fins. I'll start off by adding trapezoidal fins. This is the first of 3. Now, I'll make sure to change the thickness to 0.2 and I'll change the material to fiberglass. This will be a standard throughout the video. Let's check the apogee now. It is at 687. Note that the stability is at 0.99 cal. This is way too low for a rocket. Now let's add 4 fins. If we compare it to the apogee, we can see that the apogee has gone lower. This is good because the stability has gone up majorly. Just note, if you're looking for height records, you really want to be doing 3 fins. Even though the stability is good, let's revert back to 3 fins and see what we can do. I'll start off by changing the root chord length. I've added 20% to the length of the fin along the surface of the rocket. Now let's compare the apogee and stability. Let's check the apogee now. Our apogee is close to the original 687 meters. However, the stability is still not even 1, which is not good enough. We have to be well above 1. Now let's revert the fins back to its original. This time I'm going to change the span, or in OpenRocket it's called height. I'll add 1 centimeter. Okay, now let's see what's happened to our apogee and stability. If we look at the apogee, we can see that we have lost about 40 meters. This trade-off is good, however, because as we can see, the stability is very, very high. This can actually fly and be a stable rocket. As we can see, the center of pressure is behind the center of gravity by at least a diameter. Now let's alter the sweep angle. The sweep angle also changes the sweep length. Keep that in mind. I'll increase it a few degrees. As we can see, the apogee has gone up lots, almost reaching the original apogee at 687 meters. Also, the stability has only gone down 0.01. This is a good trade-off. We've also kept the fin height, so this is becoming quite an efficient rocket. One thing to note is that with a sharp sweep angle like this, it may be hard to make depending on what material you use. In summary, if you want more stability, you increase the height of the fin or span. And if you want apogee, you increase the sweep angle. Now let's move on to elliptical. Keep in mind that I have never actually built these fin shapes, but we will look at the theory of them. Now I'm going to revert it back to its correct material and thickness. I'll also change the height down to 4. Now we're back to our original state so we can make a comparison. Alright, let's check what we've got. We can see that our apogee is at 646, which happens to be lower than trapezoidal, which was at 687. We can also see that the stability is 2.09. This is good. Let's do the same thing with our root chord and height for this set of fins. I'll start off by changing the root chord length to 6 centimeters. The apogee hasn't changed at all, and the stability has gone down. It is at 2, so it is still okay. However, usually I'd prefer to have more stability. Now let's revert the root chord length back to 5. Let's change height up to 5 centimeters. Let's compare it now. We can see that the apogee is 612 meters. It has lost about 30 meters. This is okay. If we look at the stability, however, again it has gone up majorly. It's at 2.75, which is very, very good. In summary, this fin type is good because it keeps most of the apogee and has lots of stability, because its leading edge and trailing edge are curved. Keep in mind, however, that this fin type is very, very hard to manufacture. Now let's try something new with the fins. First of all, I'm going to change the height back to 4. Let's try changing the thickness. I'll start off by making the thickness 0.3. We can see that the apogee has gone down lots. Also, the stability has gotten worse. This is not a good improvement. At 3 millimeters, the fins may be a bit too strong for this rocket. Let's see what happens when we go down to 1 millimeter thick. We can see that the apogee has gone up significantly. However, it's up to you to determine if 1 millimeter thick is enough for a rocket. Now for fun, let's look at the placement of the fins in the rocket. I'll make sure to change the thickness back to 0.2. Let's move the fins further up the rocket. I'll start off by changing it by 1 centimeter. We can see that the apogee has not made any difference. However, the stability has gone down. This is not a good improvement. Elliptical fins are more for fun and potentially not for performance rockets. Now let's move on to my third and favorite selection, Freeform Fins. Now let's set the fins up to the same specs as the other 2 fins. I'll start off by changing the material to fiberglass and the thickness to 0.2. Now we can move on to the shape tab. To make the fins the same, we've got to make the fin height 4. You can do this by dragging down these points. Let's write down the apogee, which is 640 meters. Let's see if we can optimize these fins. I'll start off by bringing this in. Look, we already have 9 meters improvement on our apogee. The stability has also barely gone down. From here, it's important to mention that we're actually going to need to glue these fins on. We have 2 options. The first option is filleting it. What this does is it adds a layer of glue besides the surface of the fin. We can find it here. Usually the fillet radius would be between 1 to 3 millimeters. I'll change the fillet radius to 2 millimeters. Now, there is a fillet material, and I'll make that carbon fiber. This is what we use on our carbon fiber rockets. However, if you're using glue, you'll have to add a custom material. Make sure to see my other OpenRocket videos for some useful tips and tricks. If you are liking the video, please leave a like and subscribe, and also comment on what fin design you use. Now I'll revert the fillet, and let's move on to the next form of gluing your fins on. It is through the wall fins. We can find it in fin tabs. We've got tab length, tab height, and tab position. I'll increase my tab height by 1 centimeter. As you can see in the diagram, it shows these tabs. Now I'll change it to 0.6. There we are. We can see that it fits the tube of the engine. Through the wall fins are always a much stronger option and should be used whenever possible. Again, I'll revert this back. For consistency, I'll leave the fillet radius at 0 centimeters. However, in real life, you're going to need to choose one of the gluing options. Let's go to the main point of this video, which is optimizing the shape. Now I'm going to just drag a few points. You can click to add another point and control click to delete it. Another way to accurately place these points is using this X and Y chart. I'll make this 4, and I'll also make this 4. I have made the fin height exactly 4 centimeters. Now I'm going to change the X coordinates. We are still at 649 meters, so let's get into some optimization. Let's take a look at a rocket plane fin characterized by the Mark II Aurora by Dawn Aerospace. This fin is highly efficient, however it requires very high speed at all times. Alright, let's check our apogee. Look, we've got 707 meters. However, the stability is at 1.69, so I would make sure to add a bit more stability to this rocket. Now we've made it to the most important part of the video. This encompasses 3 years of practical experience. This is our recommendation. Let's go. Step 1, let's get the span correct. I'll push this up to 5. Step 2, let's get a much longer root cord. I'll make sure to reset the offset. And step 3, I'll move the rear tip back. And step 4, let's give this fin a really good sweep. The next 2 steps are our tricks. Now I'll move the outer leading edge in a bit. Our next trick is to slightly alter the trailing tip. Let's look at the apogee and stability. The apogee has gone to 659 meters, which is very good. The stability is around 2.3, which is a very nice balance. The key here is to have enough height or span to keep the rocket stable and straight. But you have to have a sharp leading edge or sweep angle to make it fast and fly high. We believe that we've got the balance between stability and apogee right. The rocket has to get off the end of the rail without tilting. Here's a bonus tip. Generally, OpenRocket makes your fins too small. That's why you should always add 20% to your fin size. This is for the extra level of security to make sure that it will perform. For our final tip, let's round the fin leading edges and see the height difference. What a huge difference! That makes our rocket go so much higher. Check it out, we now have 702 meters. A point to note is if you're rounding your edges, never do it manually. This will ruin your entire rocket. Thanks for watching this video. Do you agree with our optimizations? Tell me in the comments. And also, let me know if you have any questions.